Hey everybody, in this lesson we're going to talk about phase changes. Now phase changes is a physical change that have specific temperature curves. So what does that mean? Well, we're going to get into that as the lesson progresses. What do we know about physical change? Well, we know that a physical change is usually referred to as a change in state. Now that's another word for saying a change in phase, which means that no new substance is formed. What that means is instead what changes is only energy changes. So when you talk about energy change, you think about it as heating and cooling a lot of times. And what we also know about physical change is that they are reversible. So what are examples of physical change that we have? Well, some examples include, for example, water evaporating. When water evaporates, it is just water changing into a gas state. And that is usually a reversible state. So no new substance formed. It's still H2O. So H2O to H2O still. Other examples, ice melting, right? Ripping paper is actually an example because you're not really causing any new substance to be formed. So if that's physical change, what is chemical change? Chemical change is usually defined as any kind of change that forms a new substance. And here are some clues that this is happening. There's usually some color change, for example. There is usually some heat or light produced. Bubbles form. But here's the thing though, it's not from boiling. A solid may form, and we call this solid a precipitate. Let me fix that because it's a bit messy. Precipitate. And because of all these, this is usually hard to reverse. So what are some examples of a chemical change? Well, some examples include, for example, an explosion. Explosion is a creation of heat and light as well as new substance. Acid-base neutralization. As well as, for example, your digestion. When you digest, you're actually chemically changing the food you're eating. So those are some examples of chemical change. Now here are two videos. If you ever have time, you could YouTube them. The first one is showing you what a shockwave is an explosion. It's a pretty cool video. Second one is from Breaking Bad. It's a chemistry class video. It's about how in chemistry, it's about change. So when we talk about water, water can be involved. So physical and chemical change could involve any chemical. It could also involve a single chemical together. So here's an example of when water is undergoing physical and chemical change. So when you boil water, you're going to turn liquid H2O to gaseous H2O. This is an example of a physical change. But all of a sudden, if you put electricity into the water, we call this electrolysis. And electrolysis is an example of you taking water and you're going to break it apart into hydrogen gas and oxygen gas. So you just created a brand new substance. Now, the energy required for a physical change is actually usually a lot smaller than what you need for a chemical change. So this is the chemical change. Now, if you were to map the first example of boiling water on a temperature versus time graph, you will end up something like this. Okay, so when you look at a temperature and a time graph, so this is time on the x-axis, temperature on the y-axis. As time goes on, temperature increases. This could be, for example, ice. All of a sudden, when it reaches some melting point, for example, the temperature stops increasing. What's going on? Same thing here. Once it's all melted, it's liquid water, for example, and once it reaches, for example, a boiling point, the temperature stops increasing. So what is going on with this diagram? Well, first of all, it's not that we're taking away heat. Heat is consistently being added. So that's not what's going on. But here's what's going on. On the sloping region, okay, energy used to increase kinetic energy of the molecules. And we call this, it's used to increase its temperature. Okay? But how about the plateau regions? The flat regions? The plateau regions is now energy is not used to change the kinetic energy, but energy used to change phase. Which means you're breaking bonds. So that's what's going on. And these plateaus are what we call a melting point or freezing point, and this one will be boiling point or condensation point. And you might remember this from this diagram, where you see, based on what state is changing what state, you have a different name. Solid to liquid is melting, while liquid to solid is freezing. Liquid to gas is evaporation or evaporation. Gas to liquid is condensation. The more rare types are solid to gas is sublimation. Gas to solid is deposition. Now here's the thing though. To finish up a lesson, phase change equals a physical change. But not only that, but the slope slash plateau is only for pure substances. And the reason why is because if you have a mixture will not have straight lines, because you're going to have a lot of heating and melting, for example, of different substances at different times. So that's why it will not give you a straight line. So instead, what a mixture will give you instead is that it can actually look like, if I try to get this working, okay, a mixture on the hand will give you something like this. It might give you something like this. So it's not really a straight line, it's a bit curvy. So this is the end of the lesson. As always, make sure you keep yourself safe and healthy, and I'll see you soon.